In this video, I'm going to talk about elasticity. Elasticity describes a property of a demand or supply curve and has one simple formula: percent change in quantity divided by percent change in price. If this ratio is bigger than 1, the region is elastic. If it's exactly equal to 1, it is unit elastic, and if it's smaller than 1, it's inelastic. We'll see why we use 1 as the standard a bit later. Elasticity might not seem like much now, but it is actually a pretty meaningful concept. Elasticity describes a cause and effect relationship between price and quantity, how much change in quantity a change in price causes in different products. In this approach, elasticity is the reaction to a change in price divided by that same change in price. The elasticity of each good is different depending on how desperate people are to buy or sell it. If the elasticity of demand for a given good is very large, a small increase in its price will lead to a drastic decrease in the quantity of the good bought. This applies for goods like candy. At some market-determined price, people will continue to buy candy, but even a slight increase in the price will cause a massive decrease in sales. However, if the elasticity of demand for a given good or service is relatively small, a large increase in price would lead to only a small decrease in the quantity of the good bought. This applies to goods which consumers are very desperate, like insulin. If the price of insulin suddenly went up, people who need it aren't suddenly going to stop purchasing it. In fact, there will be almost no change in sales caused from that increase in price. The same reasoning applies for elasticity of supply. Goods and services which producers are very desperate to sell have a low elasticity, and the goods and services which producers aren't very desperate to sell will have a high elasticity. And the unit elastic supply or demand is just somewhere in between the slopes shown. Now we've seen how elasticity relates to slope, but there are still two elasticities which we haven't seen yet, the extremes. Remember the insulin example? Well, the elasticity of demand for insulin can actually better be described as inelastic, perfectly inelastic. When the demand for a good is perfectly inelastic, its numerical value is 0. What this means is that any increase in price of that good leads to 0 change in its quantity demanded. This better represents the elasticity of demand for insulin, as almost any increase in price will lead to 0 change in quantity demanded. This elasticity is represented by a vertical line because any increase in price leads to no decrease in the quantity demanded. For the same reason, a perfectly inelastic supply is also vertical. But what do perfectly elastic demand and supply look like? And what are their numerical values? You might already have guessed that they are horizontal lines, but let's check that that's true. As already established, the flatter a demand curve is, the more elastic it is. As the elasticity of demand gets larger, people are less inclined to buy that product, and the more effect the price has on the quantity demanded. At the limiting case, where elasticity is infinite, it is indeed a horizontal line. In this kind of elasticity, consumers are so indifferent to having that product that increasing its price even 1 iota results in 0 people wanting to buy that product. The reverse is true for supply. Now that we've built a connection between slope and elasticity, I want to show how elasticity determines tax incidence. Consider this problem. The government decides to levy a $2 tax on each sale of a certain good. Should the government put this tax on consumers or producers? Turns out it doesn't actually matter. Let's see why. When placed on consumers, this tax shifts the demand curve down by $2. People who were willing to pay $6 for this good now demand it at $4 to keep paying $6 in the end. When placed on producers, each charges $2 more than they used to. Either way, the price consumers pay and the price producers get ends up being the same. So they both end up at the same quantity level. This means that this tax looks more like a quota, with the difference between the price consumers pay and producers get ends up as tax revenue. But how much of a tax do producers and consumers really bear? Well, that depends on elasticity. When both demand and supply are very steep, that is to say, very inelastic, both producers and consumers end up paying more taxes as very few people leave the market. You can see from this graph, but this makes sense as both parties are desperate to trade. So more people will continue trading despite the tax. So less transaction will be forgone and more tax will be paid. When both curves are relatively elastic, both bear less burden since more people will just decide not to pay or not to buy or sell said product, so less transactions will be made and less tax will be paid. Which party bears more of the tax also depends on elasticity. When demand is very inelastic and supply is elastic, consumers are willing to pay a higher price to keep producers in the market. The opposite is true with an elastic demand and inelastic supply. When one curve is less elastic than the other, the tax burden is greater. Its tax burden is greater than the other. I guess I'll start this discussion by saying that one demand or supply curve doesn't have one elasticity. Like some curves are more elastic than others, but each point on a demand or supply curve has its own elasticity, just because it changes like that. We'll see why. But yeah. So another approach to elasticity has more to do with proportion and is practical for revenue in the context of market power. Let's say there's someone with a monopoly on good X. His total revenue is what he charges per unit times the amount of units people buy, so total revenue equals his price times quantity. Now let's say that he decreases his price from the current price by 10%, and by doing so he increases his quantity sold by 20%. Did his revenue increase or decrease? Well, the price decreased by a smaller proportion than the proportion by which the quantity increased, so the whole expression, price times quantity, must have gone up, which means that this decrease in price led to an increase in total revenue. Now he decides to decrease the price again by 10%, but this time the quantity only increases by 5%. In this scenario, the monopolist's total revenue actually decreased. How is this possible? Wouldn't a 10% decrease in price always lead to a 20% increase in quantity? Here's the sense in which I mean that one demand curve doesn't have one elasticity. When the price is really high and the quantity is really low, a 10% decrease in price leads to a much greater percent increase in quantity since the current or previous quantity was small compared to the amount by which it changed. But when the price is really low and the quantity is really large, a 10% decrease in price leads to a smaller percent change in quantity since the amount that it actually changed is very small compared to its previous value. Another approach to elasticity, therefore, is that it is the ratio of these two proportional changes. The percent change in quantity is called the quantity effect, and the percent change in price that causes it is called the price effect. Thus, elasticity can also be defined as the quantity effect divided by the price effect. When the quantity effect is larger than the price effect, total revenue increases as price decreases, and the quantity and vice versa. There is a way to see this ratio of what's gained and what's lost graphically, but first, there's something about calculating elasticity I'd like to go over. There are 3 ways to calculate percent change. The first is setting the denominator as the initial value. The second is setting it as the final value, and the midpoint method is setting it as the average of the two. The difference between these 3 methods is pretty substantial if the change in values is very large, but negligible if it's small enough, so I'll be using very small changes. Now let's do some rearranging now with our definition. Now here's the demand curve a monopolist faces. Here's his current price and quantity. Now he nudges the price down and the quantity up. Remember I'm using small nudges here to see the elasticity of a single point. When the monopolist nudges his price down, he gets some revenue from that additional quantity he sells, but loses revenue from having to decrease his price on everything else. If you did the rearranging and whatever, you can see that the elasticity can be defined as the green sliver of revenue divided by that red sliver of revenue. At low quantities, the green is bigger than the red. As you increase the output, they eventually become equal, but afterwards the red overtakes the green. That means that at the unit elastic point, the total revenue is maximized. Now we can draw the total revenue graph of the monopolist, which is hyperbolic if demand is linear. As we could see, it increases at the elastic levels, peaks at the unit elastic point, and decreases thereafter. The marginal revenue can now also be drawn. It shows that increasing output at the elastic level increases revenue up to the unit elastic level. And afterwards it becomes negative. And it's actually twice as steep as the demand curve because of the price effect represented by the red sliver of area.